In this video, we're going to get into making a multi-axis intake manifold using Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and at this point in our series, we've covered a lot of the basics about how to design intake manifolds using Fusion 360. We've talked about the basics of building the head flange, setting up our sketches, and figuring out exactly how we need to set up a parametric model so that things can update as we change them. We also looked at creating plenums that were using both the off-the-shelf runner components like the D-shaped plenum and the runners. We also took a look at using surfacing tools and form tools to build a couple different versions of the intake. We had plenums top and bottom using forms as well as using surfacing tools. After we explored these tools, we then dove into taking a look at doing this from a 3-axis CNC standpoint. Now, when we talk about 3-axis CNC, I mentioned that probably nobody would be building this, but what we were looking at doing is building components that could be machined with 3-axis CNCs. This means that we were splitting things top and bottom, and ultimately they would get welded back together, which is why we put chamfers on the edge of the plenum to give us some good penetration between the components and have them held together. We also made sure that the runners were split top and bottom so those could be welded together. And this gives us the, again, option of building all of the runner pieces, all 8 of them, using the same program and the same jig, and then we can weld everything together. Now, in reality, making a 3-axis CNC manifold is kind of a waste. You have a lot of billet material and you really have to work within constraints. And in some cases, for something like this, a K20 or K24 swapped intake manifold, it's not going to be feasible. You're going to spend way too much money on raw material and the time it takes to machine something like this. But if you want all-out performance, then we start to talk about using things like multi-axis CNCs. Now, this gives us the option of then beginning to be able to machine inside of the runners. So multi-axis CNC means that we're looking at the machine moving in X, Y, and Z, as well as rotating about an A and a B axis simultaneously. This means we can take tools into ports and down into the intake runners, and we can really get creative. However, we still need to think about the actual manufacture of the intake, which means that we are going to be building the flange, the runners, and a plate for the plenum, all as a single body, a single piece where we can get an end mill inside of it. Then the rest of it, the plenum, can be done with sheet metal pieces and welded together, or again, you can machine additional pieces and bolt them together. That is really going to depend on what you want to do. Now, since we've already talked about creating a plenum with forms, with surfacing, and with extrusions, and also the basic 3-axis plenum, I don't really know if I'm going to get too deep into that topic, but what we are going to do is we are going to build a multi-axis runner and plenum. So we're going to build everything that goes between the head and the plenum, and we're going to try to see how we can get creative with that. So as always, you can go to the description of the video. You can download what you see on the screen as our starting point, which does contain the original D-shaped extrusion plenum and runners, and it contains the surface and the form version. And then we have our CNC version. So for right now, I've got the head flange CNC displayed because we are going to take some of those elements from it, but we do want to create a new component. So this new component is going to be our multi-axis CNC. So I'm going to call this multi-X CNC, and then we're going to get started. And of course, the coordinate system is going to be the same as the coordinate system for the entire design unless we move it, which means that our origin is going to be centered on that lower bolt for that flange. Now, we can make use of some of the original data. So for example, we could go back to the original sketches and we could recreate all that. At this point, we've already done the work to create some of this geometry, so I don't really want to go back and spend the time doing that. So what I'm going to do is I'm going to select the back face of this, right-click, and create a sketch. It is important to note that we don't necessarily have to do that. What we could do is we could simply select the face and extrude it, and that would be a good start. We could also take this version of this plenum plate, and we could, the intake plate at the head, we could modify it using direct modeling tools. So either way that you want to go is fine. I'm going to hit Control Z. I'm going to expand the head flange, and I'm going to take this body, I'm going to right click, and I'm going to copy it. Note that you can also copy the entire component. We did this when we did a copy and paste new earlier on, but if you select the body, you want to right click on the component that's active and paste, and it'll stick a copy of that body in that component. Now, there will be no link back to the original. This CNC flange up here will not have any link to it. If you happen to copy the component, so for example, if I right click and copy that, and I come up here, you want to make sure that you use paste new. Paste new will create an exact copy of that instance, but it will remove the link between them. The reason that's important is because instead of just taking the body, you're actually taking all of the additional features for that component, the sketches and so on. Now, again, we are going to be building this so that the runners are going to be sort of formed in nature. We're going to expand them out as they get closer to the plenum. So what I want to do is I'm going to select these inside faces and I want to delete them. And I'm going to show you two different ways to do this. So again, this isn't necessarily how you would have to do it if you were starting from scratch, but I'm going to select those, go to modify and hit delete. And notice that it took that flange all the way back to here. Now, if that's not what you want, I'm going to hit Control Z. I'm going to select this face and hit delete. And notice that it took the port all the way back and it got rid of that inside flange. Now, if that's not what you want, then what you could do is you could select this face and you could use the shortcut key Q on the keyboard or press pull. You could select the option to do a new offset and you could come up to this face. And what that would allow you to do is as we begin to drag that out, it would allow it to just sort of go flat to there. So any way that you want to do that, it's okay. What I'm going to do is I'm going to select these faces and I'm going to hit delete because obviously if we're spending the time and energy to make a 5-axis or a multi-axis intake runner set, then obviously we're going to be porting the head and we're going to be increasing the flow. So there's no need to have that sort of smaller inner lip. And double click the mouse wheel to fit the screen. So now we've got sort of the larger port size. It's going to help us increase the flow. There's a little bit more that we want to do here. So first off, I want to round this thing. I've left this square for way too long. So I'm going to go ahead and I'm going to grab all these corners. I'm just holding down the Shift key and I'm going to hit F for fillet. Of course, you can go to modify and fillet, but learning the shortcut keys is going to help. I'm just going to round these things off. I want to make it roughly the size, in this case 12.5 millimeters. It looks like it'll be okay. Now in reality, what I would probably do is I would change the outside shape so that it more closely resembles where the bolts are. I don't really feel like that's a good use of your time, so I'm going to skip that, but you can certainly make the plate look like whatever you want depending on what you're attaching to. So now that we have sort of the opened up ports, I also want to blend these together. We don't have a lot of space with some of these bolt holes, so there's only so much we can do. So I'm going to start with one. I'm going to begin pulling this out. And note that at some point we're going to run into issues with this bolt here. We're going to take care of that in just a little bit, but I like the look of that. So I'm going to hold down Control or Command if you're on a Mac. I'm going to go and just select all the other ones and let all of those blend as well. So note that that brings up some issues with this bolt hole here. That's okay. We're going to say okay. I'm going to create a sketch on this face. I'm going to use the circle tool, which is C on the keyboard. And then we need to create a circle that is large enough diameter for whatever the head of the bolt is going to be. So I'm going to say 15 millimeters here. I'm going to do the same thing over here, except for this one, I'm going to hit D on the keyboard and just link it to this dimension. You could also use an equal constraint. Either way is going to be fine. And now we can just sort of clear that fillet out. So E on the keyboard for extrude. Once again, learning just a couple basic shortcut keys is going to be really helpful. I'm going to change the distance to through all. And that way it just relieves around that fillet. Now, because we are talking about multi-axis CNC, we do need to also think about the end mill that's going to get in there. If we're machining something from this angle, we could just take a flat end mill in there. However, we are going to not have that because we're going to have a flange on the other side for the plenum. And because it's all going to be one piece, we're not going to be able to get a tool in here, which means that a tool is going to have to come in from this angle. That means I want to add a small fillet in here so that way I can take a small lollipop mill or something that has a small radius on it and just go back in there and clean that up. So I'm going to go ahead and do that 1 millimeter. And it's not ideal, but we will be able to get a ball end mill in there and then come back and just finish it up. So it's something to keep in mind. We could just do completely away with that, but we're going to have issues when we try to machine around these. So having a nice rounded section, that 5 mm, means that I can take a 10 mm tool in there and get a little bit of chatter, or I can take something just a little bit smaller to finish that up. So this is a starting point. Obviously, we've already done some work here, but one thing we never did is we never accounted for a fuel rail. So obviously, we're going to need to attach a fuel rail, and probably the best way to do that is to find the plane that we used to create, to originally create these faces, or in this case, just sketch right on one of those faces. So we need to determine where those are going to be. I'm going to hit P on the keyboard or go to Project, Include, Project. And I'm just going to grab all of these faces. And the main reason I'm going to do that is because the fuel rail locations are going to be in the middle here. So using the line tool, also L on the keyboard, I'm going to go from there to there. I can hit OK. And I want to go from here to here. The main reason that I'm doing that is because this gives me a center point location. X on the keyboard to make that construction, or you can click construction here. You can also double click on these loops, turn them into construction. We don't actually need them for anything except for a reference. We could have just brought in the center and that would have been fine, but sometimes it's just quicker and easier to select a face. Now, keep in mind that in order to do stuff like this efficiently, shortcut keys are going to be somewhat critical, but also the right-click marking menu can really help, because a lot of times, based on whatever you have selected, you'll get an option that is specific to that. So for example, converting it to construction tells you exactly what shortcut key is, in this case, X. All right, so now we've got the center location for where the fuel rail is going to mount. If there's going to be 3 mounting points, and obviously you need to account for that. So then C on the keyboard, and I'm going to just go till I find that triangle. It's my midpoint. And I'm going to draw 2 circles. I'm going to create a boss. This boss should be able to be machined, but we still need to blend it into the plate. So you can either carry this entire flat section between the injectors, or you can just make the boss here. So let's get started with the boss method. I'm going to start by making this 6.5 mm. Obviously, you need to make it whatever size you need for tapping, and I'm going to make that 15. Then I'm going to use the equal constraint between these and that. So if you wanted to do just the boss method, we'll explore that first. I'm going to extrude those, so E on the keyboard. I'm going to say to object, select the plate, and you can see that it's just extruding it down to the plate. It's not going through. That obviously will be a little bit tricky on the inside because you're not going to be drilling down to that plate angle. So usually what I would do is for the profile, I would select the inside and make it a solid boss, and then I would go back and drill that hole out. So that way the hole can actually have a drill point or a flat bottom. So if you're going in with a small end mill to clean it out, or if you're using a drill bit, you wouldn't have that weird face that matches the plenum on the inside. So that's how we would do it if we were just going to extrude the boss. But let's go back into the sketch. I'm going to double click. And this time what I want to do is use a rectangle. I'm going to use center point rectangle from here. And I'm just going to bring this out and to the right. And do the same thing over here. And then I'm going to use my equal constraints just to make these equal. Keep in mind that we could also use things like collinear, especially when things are in line. We could use collinear for the top and bottom, but the centers are already located, so it's just over constraining it at this point. Okay, so now that we've got this rectangle, we need to figure out what size it needs to be. And you can see that it's growing left and right. That's not what we want, but we do want to grow it up and down. So what I'm going to do is I'm going to use my tangent constraint and just make it tangent with that 15 mm diameter. I'm going to hit escape, and then I'm going to bring this back over. What I want to do is I want to make sure that it sits inside of this edge. Even though I'm not extruding all the way to this face, I want to make sure that it's at least touching or inside. So I'm going to select these, make them coincident. And that should fully define things for us. Next, what we're going to do is, again, E for extrude. Again, I want to select that inside section. I'm going to do everything over here as well. Because that original sketch plane wasn't construction, we need to make sure that we do select that small section in there. So now that we have this, if your injector or fuel rail is going to be there, then you can just go ahead and extrude it down, noting that we are going to have some issues in this area that we're going to have to address. I don't think it really needs to be that high, so I'm going to offset it from the plane. I'm going to try to go in the -5 mm direction. I'm also going to say join. So I want to see what this thing looks like when it goes together. You can see that we still don't really have the clearance for that bolt hole, so this is going to present a problem for us. And obviously, we're going to have an issue machining that corner. So this solution doesn't look like the best solution for this geometry. So all we really need to do is change the selection and just go back to our bosses. Again, I'm going to select the inside. I'm going to add the holes after the fact. And then the hole, those bosses will be there. Now, we don't necessarily have to have it centered if it's causing issues with that boss. We could also raise it up or lower it down. So depending on the fuel rail that you're going to use, depending on the geometry, then obviously you can play around with the locations a bit. But for me, what I want to do is I want to make sure that I do create it in the right location, at least centered for this case. Again, it's going to cause some issues here, and we do need to blend the bottom of this. So F for fillet. And you'll note that it didn't actually go all the way down in this extrude, and that's because I ended up not using the extrude to object, and that's really important. So in this case, make sure that we go to object. That way it goes all the way down. So F for fillet. Let's do both of them. Rotate this around. And again, we want to make sure that we have a nice blend here, and you can see that it's causing issues because of the size. And again, it's going into that boss right there, that hole where the screw is going to be. So obviously needs a little bit of adjustment. And again, depending on your fuel rail, these are probably going to be lower. But I'm going to say okay for now. And then I'm going to go back to that sketch and adjust it. So if you make decisions like this where you've got this line right here that's driving everything, it can be really tricky for you to figure out how to sort of unhinge that. But if you select the center points here, you can see there's a coincident constraint. We can select and delete that. We'll do the same thing over here. And then this line should be able to move. Now, obviously that causes problems over here, so we need to do the same thing over here. And what I suggest is that we start to drag it down, and then we use a horizontal vertical constraint between the endpoints. So that way we still have it in the same location relative to the injector bungs, but we are going to have to do a little bit of work to sort of plan where that goes. Remember, we didn't end up using these rectangles, so just converting one of those lines to construction using X is a pretty good solution. And then we can use D on the keyboard and give this a dimension so that we can come back and modify it. So I'm going to say 14 millimeters, and then we'll finish the sketch. So that moves it down, it's out of the way. We still have the mounting point. We could go back to using the rectangular extrude here, but again, that looks okay. It's giving us that location. It's going to be tricky to machine, again, because of this section here. You really have to think about the size tools that you're going to use. That is probably not ideal, but I don't want to kill a bunch of time just messing with this. So I'm going to move on to other geometry. The next thing that we want to do is we want to figure out where the plenum is going to be in this version. Now, we've got our throttle body flange. If we want to stick to that location, then we can. One of the benefits of doing a multi-axis intake, or at least runners in this case, is that we can get really creative with the geometry. One of the downsides is we're going to be limited for tool axis and tool length. Now, different types of tapered end mills or lollipop mills are able to get pretty far into ports. However, we have to be careful because we would essentially be removing all of the material. So while we can get creative, we should be mindful of what that really is going to look like. So I'm going to start by creating an offset plane. I'm going to go from this flange. I'm going to view this from the top. I'm going to begin to pull this out. I think I'm going to go about 75 millimeters. That's going to be pretty long for a tool to reach in there if we have to go around any corners, but it is going to give us something that looks pretty cool and give us enough time for the airflow to sort of normalize. Now, when we did that, we need to think about the location of each port. Now, remember, in all of the other versions, we simply drew one port or one runner, and we did a linear pattern at 86 millimeter spacing. That is not really going to be the same thing that we want to do here, simply because we're going to be lofting the shape. So if each one of these runners is going to be exactly the same from each port, then that's perfectly fine. We can do the pattern. If they're not, then you really need to make sure that you draw each of these. Now, what I want to do is I want to think about the area inside of here. Now, when I think about the area inside of here, I need to be able to select something. So I'm going to hit P on the keyboard, and I want to grab this entire inside profile. I'm going to say OK. And then I'm going to use I, which is inspect measure. I'm going to select this here. And I've noticed that recently this measure dialog has required me to scroll down if I pre-select something. But if I hit I and then select it, it'll expand. I don't know why it's doing that. But basically we're looking here, we've got 1,780 square millimeters. That's the area of that port. And what I'm looking to do is I'm looking to have the size of that port at the plenum be larger. So I want to increase its size so that we're tapering down and we're increasing the velocity of the air when we're off boost. Once we're on boost, all bets are going to be off. So what I want to do is I'm going to start with just a circle, and I'm going to offset it from the port a little bit forward. I'm going to just start it here and come to the left a little bit, and I'm just going to create a circle and hit escape. Now, the first thing I'm going to do is come in and I'm going to make sure that we are horizontal with this. I don't really want to go up or down, but I still want to be able to float left and right a little bit. And then I want to use that inspect measure and just measure the area inside of that circle. Now, it gets a little tricky, so I'm going to come back and make that original port all construction. And then I'm going to use inspect measure and measure this. So you can see that the area inside of here, before we were dealing with just shy of, 1,800 square millimeters, and now we've got 2,600. So we've gone up 800. That's probably a bit too much. So I'm going to decrease that a bit and then just remeasure. And then again, I on the keyboard. And you can see now we're at about 2,000. So I think that's a pretty good increase. So I'm going to use D on the keyboard, and I'm just going to bump that up to 52 millimeters. And for right now, I'm going to give it a 17 millimeter offset to the left. Now, another thing that we need to keep in mind is the distance between the wall thickness, I should say. So P on the keyboard, I'm going to project that point. And then I can use L on the keyboard to put a line there. I'm going to turn it into construction. And the reason that I want to do that is I can put a circle here and I can put a line between these two. I'm going to make sure that that line is vertical. I'm going to hold down Control or Command to the origin, and I'm going to say coincident, which will make sure that it extends into that point. And then I'm going to turn it into construction. Now, the reason that I'm doing this is because I can take that line and this line and I can make them equal. We could also measure and add a dimension, but doing something like this means that if I ever go back and I change the thickness of the sketch that was used to define that, then this thickness will update as well. So from here, let's finish the sketch. And what we're going to do is we're going to use create and loft. Now, with loft, when we're doing it as a solid, I'm going to select this face and then this profile. And notice that I'm getting an error. Now, it says that it can't be created because of the inputs. Now, you'll notice that we have it connected here. In some cases, the reason for that is because of the geometry. What we can do is we can clear out these profiles, and instead of selecting that, we can try to select an edge. But notice that it's not working. It's just grabbing all that geometry and it's not liking it. If this happens, you have to play around with some of the options, but sometimes it's easier to go in to do create, loft, and loft will actually allow us to use the outside edges. And then what we want to make sure we do is we add a tangency constraint and a direction constraint. Now, the reason that we want to do this, tangency works because we have a surface down here. Here we only have a sketch, so the only thing that we can do is give it a direction. If you want it to taper, so for example, with direction, we want a takeoff angle of say 10 degrees. We can have it start to taper inward or outward depending on the direction that we're going. Now, the reason that that's important is because if we plan to do something like a bell mouth or a bevel as it goes into this runner, then we can start to account for that here, so we don't have to do everything in the next feature. But in this case, I'm going to leave it at 0 because it's going to make the port size a little bit larger and not restrict it or narrow it down. But these are things that we can plan for. Now, remember, we are going from a round profile and we're going down to that sort of oval profile. So from the side, you can see that it's a nice smooth blend. From this direction, can't really tell all that much. From the top, you can see that it looks to be the oval part is wider than the circle, but again, we measured the area, so that's really what we're looking at. So I'm going to say OK here, and notice that it gives me an error. Now, let's look at the more information. The loft would flow in an invalid direction. Try adjusting the continuity settings. So if this ever happens, oftentimes it's because of the selection. We just have to try again. So let's go ahead and just select everything here, select the outside. Once again, we can try tangent here. We can try direction here. I'm going to keep the tangent edges. Sometimes this can be helpful. Sometimes it can hurt. We'll say OK. And again, it's causing an error. So one more time, it's telling us that the loft is an invalid direction. So I'm going to give it one more shot, and then I am going to try something different. We'll grab those, grab this. For this one here, let's try curvature, and again, direction, and we'll say OK. So you can see for some reason, it just does not like this loft. The way that I'm going to get around this is I am going to create an offset surface, and I'm going to turn off chain selection. I'm going to grab all these outsides here, and then I'm going to hide my solid body. So hide that, so we're only dealing with this surface. Next, I am going to extrude this outside profile, just bring it out a little bit. And now I've got two surfaces to select. Sometimes it'll do a little bit better with this than dealing with the edge of a solid. Just need to select this. And now we should have tangent on both sides. And we'll say OK, and it was fine with that. So sometimes you run into these issues and you need to do a little bit of a workaround. Unfortunately, this wasn't too bad, but it's always going to be frustrating. So I am going to remove those surfaces since I don't need them. We need to thicken this, and unfortunately, because of the way that this was created, we don't actually have that dimension linked to the sketch anymore. One thing that we could do is repeat this process and loft the inside shape, and it should be consistent, but we don't really know if it's truly going to be a consistent wall thickness. So the way to think about this is to really just to measure. So I'm going to go to inspect. I'm going to go to that point, and there's another point up here, and it says 3 millimeters is the wall thickness we used. So under create, thicken, we'll grab this and we'll do 3 millimeters, and that should give us a solid body. And because we are tangent in the direction of the start and the end, that 3 millimeters should be fine. It's going to create a new body, and it should perfectly line up with the port on the inside. And again, because of tangency, because these were extruded, this was extruded, it should all line up fine. So that looks pretty good. The shape is good. The blend is good. Everything sort of gives us the right shape. So now we can create that linear pattern. So we're going to go rectangular. We're going to pattern a body, which is this solid body. The direction, it can be X. It can be this linear edge here. We're going to go out 4 instances. We're going to do a spacing of minus 86 millimeters just because of the direction of X. And this gives us ports that match everything here. So again, what we're doing is we're sweeping forward. We're sweeping away from things on the firewall like the master cylinder, brake booster, and it gives us a little bit more room to play with. At this point, I'm going to go back to my solid tools, and I want to combine this flange with each of these bodies here. Then anything left over, if we've got any surfaces, we can right-click and remove them just to clean up the browser a little bit. I realize I haven't saved yet. Let's go ahead and save, make sure we don't lose anything, and we can move on to the flange at the plenum. So one of the cool things that we can do from here is we can play around with the numbers, and everything should update properly. Now I say everything should because sometimes you get caught off guard by these things. So For example, the offset plane, if we want to modify this, let's go ahead and double click on it. And let's increase this to 80 millimeter. Actually, let's go to 85, just a little bit longer, 90 millimeters. And you can see all of the runners update just fine. Now, if we go back to the sketch that was used to create this, let's expand the sketches. Sketch 3, I'm going to right click and I want to show dimensions. So here, if I want to increase the port size to 54 millimeters, all of them increase. If I want to increase the offset to 20 millimeters, all of them shift over. And just playing around with the numbers can help us get a better idea, especially since we just went through and we patterned these. As long as it lines up with the first one and we have the pattern instance distance correct, then it should be pretty simple for us to make those updates. And again, that's the benefit of doing this in a parametric modeling sense, because we can make sure that we can go through and we can create the things that we need, the geometry that we need. And as long as we follow some basic rules, then we can have things update properly. So at this point, we need to figure out what the plenum is going to be. Now, the main thing with the runners is going to be machining inside of them, right? So we can see straight through here, which means that we could take a large end mill and we can clean out the majority of the material, and we could do it from this side as well. And in reality, this, because of the shape of the ports, this could be done very creatively with a 3-axis machine, right? We could go in there with a large mill, we could get as much as we could from this side, and then we could come back and we could clean up the rest from this side. There are some areas that would get tricky. We would probably require some hand porting or some custom fixturing, but it could theoretically be done. And again, with things like the injector bungs and fuel rail mounts, those things could be done with some creative fixturing and some different angles getting at this geometry. But what we want to think about is what the rest of the plenum and the intake is going to look like. Now, there are plenty of intakes on the market where it sort of stops at this, and then the rest of the manifold is sheet metal, which is something that we haven't actually covered yet, which would probably be a good thing to do. And then, of course, we could make the intake as intricate as we want. But given the fact that we've talked about basic plenums with off-the-shelf components like the extrusions, we've done the plenums with surfaces and with forms, and we've done the 3-axis inspired CNC intake. Now, I think it would be pretty helpful if we took a look at sheet metal and we talked about some of the sheet metal tools and how we can use those. So then the next thing that I need to do is I need to create the rest of the plate that's going to attach. And again, this plane that we created is where all these runners end. So I'm going to right click and create a sketch on it. I'm going to revert position. If I moved anything, make sure that we do revert that position. And then I'm going to use P on the keyboard, and I'm just going to bring in each one of these faces. Now they should all lie in this construction plane. So all the geometry should be right on the solid, so everything looks good. But I just want to bring that in so I've got that as a reference. And the next thing that I need to do is I need to create some geometry that is going to represent the plate that we're going to weld to. Now, the way that I'm going to do this is with the line tool. I'm going to go between the centers of the two middle ports, convert it to construction, and that's going to give me a center point for a center rectangle directly in the middle of all this, so I can keep everything centered. And then I need to decide how long that's going to be. So I'm going to go 350 millimeters, I'm going to hit tab, and I'm going to make it 75 tall. We could dimension from one of these and that would be fine, but this gives us sort of that good starting point. So from here, I'm going to just extrude this. Now at this point, we need to think about the rigidity of the material. Now, what I mean by that is we're going to have to machine this, so we need to think about how thick this needs to be. 10 millimeters is probably a bit much, but I'm going to go ahead and do that. The next thing that we want to do is we want to create some sort of bell mouth or rounded section going into this. Now, the trick to this part is going to be that we've already got a sketch for the center location right here. And also the last sketch has a center location for all of them. We know that we can create a plane directly in the center of that, and then we can just pattern whatever geometry we create. So what I'm going to do is create an offset plane. I'm going to pick, in this case, It's going to be YZ. And we're going to go to an object. I'm going to select the center point here. That'll maintain a parametric link. And that's going to be an important factor. That parametric link means that if we move this port, that plane will move with it. Now that we have that, I want to sketch on that plane. So I'm going to take plane 2 and create a sketch. For the time being, I'm going to use slice so we can see inside of that. And then I'm going to use project include. And I'm going to use intersect. Now, intersect is going to give me the top and the bottom edge here. I'm going to say OK. And the reason that that's important is because now we can use our line tool and we can find the midpoint. So I'm going to go from this end to this end. And now we've got this sort of midpoint. That midpoint is going to be our reference for a revolution axis. I'm going to hit escape and turn these all into construction because I don't need them for selecting any geometry. And then we need to think about how wide that bell mouth piece is going to be. So I'm going to start with my line tool. Remember, we only have to draw half of it because we're going to revolve it. But I'm going to start to come out. And then once I'm here, I'm going to go back to that last point, hold down the left mouse button, and I'm going to start to create this arc. I'm going to come horizontal, or in this case, it's going to be vertical. And I'm going to just come back down to this plate and back over to this point. Now I want to make sure that this line is perpendicular here, or we could just make it vertical because of the orientation of what we're working on. So before I give this any dimensions, I'm going to finish the sketch and I want to revolve it. So the axis of revolution is going to be in our sketch, and I'm going to create this as a new body. We could create it as a feature and pattern the feature, but I want to look at the shape in 3D before I commit to it. One thing that we can do is we can go back to the sketch and then we can start to add those dimensions. So I think what I want to do is I want to bring this down. I'm going to give this a dimension here of 7 millimeters. I'm going to hit escape, and then I want to sort of make this more of an arc and make these two tangent. So that's going to give me a full arc, full 90-degree sweep, and then I can use D for dimensions. I'm going to make this 3 millimeters. And give this a radius value of 6, and that'll give me a fully defined sketch. Now that I have that fully defined, I could show the sketch, I could right click and show the dimensions, and we can modify these on the fly. So if I wanted to push that out a bit more, I could say 4 millimeters and push it out. And if you want to see what's going on inside of it, you can select your plane, go to inspect, and create a section analysis. So the section analysis lets us see inside. We could increase or decrease these values. The 7 I could take to 8. The 6 I could go to 6.5, make it a little bit larger. And now we're sort of playing around with that shape. The bell mouth is an important aspect of intake design, but there are pros and cons. There are benefits to using it in some instances, and there are going to be less of a benefit in other cases. Now, when I say benefits, when we're talking about breaking some of the friction or the tension in the air and getting a clean entry into the runner, that's going to be very important off boost if you're dealing with a normally aspirated car. When we're dealing with a boosted application, then we have to think about the air getting pressed into corners. We have to think about heat. We have to think about friction. There's all kinds of things. But ultimately, boost overcomes a lot of that. So we just need to make sure that we're designing for off boost, especially if you've got a lot of lag, and then we can sort of plan around it from there. Now, one of the things that you would want to think about is whether or not these should be removable. Now, if you're going through the process of designing something like this, 3D printing it and doing some flow testing is a great way to decide before you commit. Now, you can get away with 3D printing a lot of stuff under the hood. This bolted directly to the head would probably be outside of the realm of something I would do unless you were 3D printing from metal, which would be way more expensive than doing a multi-axis machining operation. So keep in mind that 3D printing can be helpful on a flow bench for stuff like this. So I'm going to do a pattern of the body. This is the body. The direction again is X. I'll just select this edge, begin dragging this out. We're going to go for spacing of minus 86 millimeters. And now we've got one for each of those. I'm also going to fillet these corners. While they don't necessarily need to be rounded because we are going to be, actually, you know what? While I'm thinking about it, I'm not going to fillet them. And that's simply because we're going to be welding sheet metal to them. So I want to leave them square for now. But I do want to combine everything together. So intake and all these little pieces, I'm going to say, okay. And now we've got the sort of 5-axis part of this done. All right, so we're going to do a quick save, make sure we don't lose anything. So we've got some interesting ports. We're going from a larger diameter circle to a little bit smaller oval. We've still got the injector bungs, the 14 millimeter. We've got some bosses that can be used for the fuel rail. Until there's actually injectors and a fuel rail in here, we don't strictly know where they're going to be. These would likely be better off on the runners because we are machining it. But again, that's something that sort of maybe comes later. So I just put them there as placeholders. Once there is an injector rail and injectors, that's kind of the best time to decide where those things can go. But ultimately, they would probably be better served to be on each runner. To just kind of take a look at what that would be, let's go ahead and just sketch them. So in order to do that, once again, I'm going to go ahead and make sure that I create a sketch on this face. P, I'm going to project each of these. Actually, you know what? Let's just project the injector location because we don't need everything. We just need those center points. And then what I want to do is I want to place a boss on each of these. Another thing that we could think about doing is creating an offset plane exactly where we want those, that offset plane from here. And actually, you know what? Sometimes going through this process, I change my mind as we're designing, and that's okay because that's kind of how it happens in the real world. And as I mentioned before, we are going through this sort of together. I haven't designed this part before. Of course, I've looked at different versions of intakes online, and I've done enough with different intakes, but we're kind of going through this from scratch together. So I just offset that 40 millimeters. I'm going to start a new sketch. And the benefit of this is when we use slice or when we use intersect, we can see exactly where we're hitting the runners. So I'm going to use create, project, include, and intersect. And I'm only going to do one of these, mainly because we can pattern them. I only really need to draw once. And what I want to do is I want to create a bung that is exactly centered with the injector. So P on the keyboard to project that circle, L for my line tool. I'm just going to draw it straight down. I don't really need to draw this line. It's just there as a good reference. And then I'm going to do a circle. I'm going to say at least a 10 millimeter diameter. But I want this to actually have a rectangular pad. So I'm going to bring this down, over, and down, and just sort of connect these two together. And what I want to do is I want to make sure that these are tangent. So let's make sure that these are tangent here, and this is tangent. Looks like there's some extra lines that happened in here. Go ahead and delete those. All right, so everything's tangent there. That can still float up and down. There is a horizontal line here. I don't know why there's all these extras. Let's go ahead and just drag these over. All right, so we can make sure that this is at least in the center here. So what I'm going to do is I'm going to hit D on the keyboard. I'm going to give it 11 millimeters. That'll define where that is. I'm going to determine that this is going to be 18. Looks like I need to add a little bit here. So let's make that 12. And now that's fully defined. So we're going to finish the sketch. E for extrude. I'm going to take this entire thing, and we are going to extrude it to object. Now we're going to do this as a new body, and sometimes this doesn't work when it's actually going through that solid. So you can see here that it's going through the solid. So one thing that we can do for our profile is we can get rid of that. And because that perfectly matches the plane and the intersection, you can see that it works just fine in this case. So this is a new body, and we're going to say OK. And then we can pattern that. And again, because all the runners are the same, this pattern is going to be fine. Select a linear edge, drag it out for spacing of 86 millimeters, and now we can combine those together. So again, this is just a different way. It just kind of depends on what your goal is, where your fuel rail is going to be bolting, if there's any, spacers or anything. And then we can use a fillet. I'm going to just do a small round here, maybe 1 millimeter, and then fill it one more time. This time I'm going to blend around the outside. This probably isn't going to let me do a very large. It looks like it'll go pretty large. I'm going to go to 5 millimeters. Again, keeping in mind the size of the tool. Make sure that we got 5 there. And that's okay. Now, if you ever want to go back and sort of get rid of some of this other stuff, so this fillet here, I may not want to completely get rid of it, but I can suppress it. And that boss, I can right click and I can suppress it. So that way it's still in there, but you'll notice that it gave me an error here. The combine is an error. And the reason this happened is it purely for the fact that originally when we combine things, it changed the name of the object. And when we change the name of the object, then we produce problems because it no longer knows which solid body we're trying to connect with. But that looks pretty good. So now we've got those pads where we can have 4 different bolt points for a rail. And again, we can get as creative as we want. It's kind of hard to do without having a rail in the design. Let's go ahead and save that. All right, so now that we have this, the next step for me is to keep in mind that sheet metal, each sheet metal piece that we have that we want to flatten is going to require its own component. Now, in order to organize this, what I want to do is I'm going to turn this body into a component. First, I'm going to rename it. I'm going to call this 5X runner, and then I'm going to right click and turn it into a component. Now, this automatically makes this multi-X CNC component have subcomponents in it, which is perfect. With it active, I'm going to go to sheet metal and start a new sheet metal component. When we do this, we have to think about the component names, what they're going to represent, and their material. So we're going to use aluminum millimeter, and I'm going to say okay. And everything else changes opacity because we're inside of this new component. Now, the first thing that I want to do is I want to go into my sheet metal rules, and I want to see what this aluminum rule is. Now, it's got a thickness of 2 millimeters. If you remember, we made the wall thickness of the runners 3 millimeters. And we can see the K factor here is 0.44, probably about normal for an aluminum, probably a 2 or 3000 series. And everything looks good. If we want to modify this, we can create a new rule, or we can edit this rule. If we edit this one, it won't change the one that's in the library. It'll only change the one in this design. So for example, if we wanted to go to 3 millimeters, then we could simply do that. If we want to modify some of the bend conditions, which are automatically linked to thickness and a variation of thickness, then we could do that. We can also override these during feature creation. So I'm going to close that now that we're at 3 millimeters. And I want to get started designing the top of the plenum. So I'm going to select this top face. I'm going to create a sketch. And I want to take a look at where the throttle body plate is. So this is where I need to go. And it is a little bit higher than where this piece is, but in reality, it's going to be easier to just put it at the same height. So what I'm going to do is I'm going to just sort of account for that generally. So I want to take my line tool and I'm going to come out a little bit. I'm just going to give it a small straight, and then I'm going to use an arc and then a horizontal here. I want to make sure that these two are going to be tangent, and then that is going to drive sort of the size of that arc where it lands. And this point right here is going to be at the front of my throttle body plate. So if I want to link them together, I can project one of those edges and I can make them coincident, for example. And then I can start to use my dimensions. So I'm going to give this at least 5 millimeters there, and that looks like it fully defines that. So essentially what we're going to be doing is we're going to be using our line tool, and we're going to be driving this design. So I'm going to come back a little bit straight, and then I'm going to start to arc back a little bit. And again, I'm going to come straight, and then I'm going to arc back and a straight line, and we'll sort of fix all the geometry. So let's make these tangent. I'm going to make this vertical. And then we can sort of decide what these values are going to be. We can see we've got tangency between those. We've got a straight line here. I'm going to say D on the keyboard and just give this a value. I need to link it to this. So P on the keyboard, I'm just going to project that edge. I'm going to make it construction, and then I'm going to snap those together. So that locks that in place. I'm going to give this a dimension back here. Let's say 50 millimeter radius. We'll bring this out 50. And then all we have left is this large arc and this sort of section here. So I'm going to give this an angle. Let's say 110 degrees, and that should fix everything else. So I'm going to take this edge, X on the keyboard, and that gives us one section to select. So I'm going to finish this, and there are two ways that we can really get started with a sheet metal body. The flange tool allows us to take a single edge. So for example, if I turn off chaining and I just select this edge, I can create a sheet metal piece that is of the thickness that we defined with our sheet metal rule using that edge. And it can go on one side, both sides, symmetric, and we could do that. Or we can select an entire profile. So I'm going to turn chaining on, select this profile, and then I want to make sure that this goes in the correct direction. So I'm going to make sure that it goes to side 1, which is up away from our flange over here. And again, we're not really worried about the throttle body plate just yet. I'm going to deal with that in a minute, but that looks pretty good. We'll say okay. Keep in mind that this is just purely flat on top. So this is going to be something where you get it water jet. You could send it out to somewhere like Send Cut Send and just get these pieces back and weld them together. If you want pieces that have a bend to them, it gets a little bit trickier because large radius bends are going to really be based upon tooling. But at this point, let's go ahead before we go any further. Let's make sure that we save. We don't want to lose anything that we've done, and we want to make sure that we've got a good save point. So now that we have the top plate of the sheet metal component, let's go ahead and call this one intake top. And then we want to go back and activate the multi-X CNC. Now, at this stage, we should think about a couple of things. We should think about exactly where the welds are going to be, how you're going to overlap the parts, because typically what you would want to do is you want to make sure that you have thick enough material, and you also need to think about where the pieces are going to be to weld them. Now, obviously, this back plate here is quite a bit thicker, and likely you would want to preheat that some way. You can see that this top plate is just flat. The bottom plate is going to be a little bit different, just simply for the fact that the throttle body is larger than the height of this plate. So we need to think about a couple of things, and let's get started by making the next component. So at the top level, we're going to create another sheet metal component. This is going to be our intake outside. And we're going to activate it. We're going to say OK. And once again, we need to make sure that we're using the correct aluminum. So we didn't rename this first one. It's still in this design. And what I want to do is I want to edit the rule. And I'm just going to put 3 millimeters inside of the brackets. So that way, when we're looking at these rules, we know exactly which one is being used. You can always expand the component and see which rule is being used. And in this case, let's make sure that we are using the 3 millimeter one. So now that we've got this new component, we are going to, in this case, I'm going to start on the top of the old piece. And what I want to do is I want to use this outside edge. So I'm going to select that top. I'm going to create a sketch. This automatically brings in everything I need. However, I'm going to use X on the keyboard to get rid of some edges I don't need. And then we're going to finish the sketch. So it doesn't look like much yet, but let's go ahead and use the flange tool and let's select this upper edge and drag it down. So what this allows us to do is build that outside piece, and we're going to have to trim it away. It needs to be tall enough for the throttle body. And so what I want to do is drag it down. It looks like 85 millimeters will be okay. If we want to, we can use the option to go specifically to that distance. Like we can select a point here and it'll measure that for us. It's not going to create a parametric link, but it will measure that distance for us. Now, the throttle body plate we end up using is not going to have a fillet here just because There's no reason to weld that. And it'll probably be a little bit thicker because we don't want this just passing hole. We'd want a blind hole so that we don't get air leaks and have to put a bunch of RTV or goop on the threads. So that looks like it's pretty good there. And I'm going to say okay. And the next thing I need to do is I need to figure out how to make this plate stop at that face. And we need to think about this a couple different ways. The reason we need to think about this is because we are going to have to manufacture these parts. So whatever happens here, we need to make sure that it's something that can be manufactured. So if it happens relatively quickly as we get away from the throttle body and then out, but what I would suggest, at least in the case of this design, is that it happens within the space of this flat, that we taper it down inside of here, or that it happens in the space of this back flat. So we need to make it happen relatively quick. Now, so what I want to do is I'm going to make it drop. I'm going to sketch on this face. I'm going to rotate this up a little bit using P on the keyboard. I want to project that bottom edge so I know exactly where it is. And from this front edge, we need to sort of taper it up and over. So using my line tool, I'm going to snap to this bottom edge, and I'm going to come up to here. And that cut would be fine, like we can make that, but we have to think about the radius of the bend that's going to happen in this corner. So I'm going to say fillet and see if it'll let me fillet this, and you can see that it won't because it's a projected edge. So hit escape. Let's delete this line. Let's turn this one into construction. And let's use the line tool once again. So we're going to come horizontal, then we're going to come up to this line, and then we're going to go horizontal through the entire thing and say okay. So we snapped to that line, but now it'll let us do a fillet between this and between this. Now, 2 millimeters is going to be a pretty tight bend. Remember that we're dealing with 3 millimeter thick material, and generally the bend radius is, at the very least, is going to be the thickness of the material. Generally, you don't really want to bend it that tight. It's going to leave a sharp corner on the inside. That is, again, it's going to be dependent on the technology that you have to make these pieces. If you're sending it to somewhere like, again, I mentioned Sencut Sen, they're pretty popular right now. If you're sending it somewhere like that, then you have to work with them and see what their capability is. So that looks pretty good. I'm going to right click and OK that. Then I need to add some dimensions. So D on the keyboard, let's just say 20 millimeters back. Let's give this, let's say that this is 10 millimeters. That's going to be horizontal. We'll fix that in a second. I'm going to go from this point to this point, and I'm going to give that 50 millimeters. And I need to make sure that this, actually this line and that line are collinear. And then I also need to make sure that this line is horizontal. So it gives me a nice clean cut. This one out here doesn't really matter as long as it extends outside. So we can just give it some value that's longer than our part. We could snap it exactly to the right location, but this gives us a little bit more flexibility. Now that we have this, we can do a split body, but you'll notice that we don't really have the split body option in here like we do for other solids. What we really need to do is we need to create an extrude cut. Now, when we come over here to our create menu, you can see that again, we've got a couple of different tools. We've got extrude and hole, but we don't have the ability to sort of use that to split the body. We can go back to the solid tools and do that, but probably the easiest thing is just to take a line and just build this as a closed profile. So I'm going to come over horizontally until this point here where our horizontal line starts and just sort of close that off. So now that we have this, we can use extrude and we can take this entire thing and it needs to go back and through, and I'm going to say through all. And because we're inside of this active sheet metal component, notice it's not cutting through anything else. In the objects to cut, we can verify that it's only that one body. And now we've sort of created that piece. Now there's a final check that we want to do here. So let's go ahead and create a flat pattern. The way that we do that is select create flat pattern. We pick a stationary face and we say okay, and just make sure that this thing can be flattened. So This is how you would send it off to be cut. We've got the center line of this large bend. We got the center line of this bend. And when we finish the flat pattern, it'll go back to its folded shape. So I'm going to go back to this top piece here. I'm going to save real quick. Now, keep in mind that this doesn't look super great, right? I mean, this is just a sheet metal box that we're making. But again, this is, I've built a turbo manifold this way for one of my motorcycles, just doing it with sheet metal pieces. And one of the benefits is that when you're doing this out of aluminum, if you've got a piece like this top and potentially the bottom, you can start to tack the sheet metal here and start to bend it around. You can get it pretty close. You can use some clamps. You can tack it along this bend, and you can get it to bend and conform to this outside shape. Obviously, you could do a bit more for different shapes and different forms, but that's the sort of the general process. The bottom piece is going to get a little bit trickier, and what we're going to end up doing is we're going to end up trimming it very similar to the way that we did this piece. But what I want to do is I want to get started with, again, another new component. So we're going to make sure that our multi-X CNC component is active. This one is going to be our intake bottom. And we want to make sure that we use that 3mm rule and we activate it. I'm going to start a sketch here. And what I want to do is I want to make sure that front, the top, and this line are all construction. That leaves me this bottom piece here. And from here, we know that we can just create a horizontal line. And again, I just want to make sure that it's long enough that it goes outside of the entire design because we're going to trim it. Then we're going to create our flange, selecting all these pieces, and we're just going to pull it back this way. Now, it tells me that it can't offset it. What we want to do is we want to try to modify some of these values. It says it can't offset the value. The tool body creation is failed. So if that happens, then oftentimes what that means is the profile that we're selecting is not working. Let's go ahead and let's try to go the other direction. Let's reselect this edge, and you can see that it does not like this edge. So what I'm going to do in this case is I'm going to go back to the sketch. I'm going to go back to the sketch that we used to create the cut, and I'm going to hide the body, but I'm going to project the sketch. So this line, this right here, this little fillet, and I'm going to say okay, and I'm going to connect these. So likely the problem that we're getting is that 3mm is just too small. And that's something that is something we need to be mindful of. So let's try one more time, see if it works with this. And I'm going to guess it doesn't. Okay, so the way that we fix this is we go back to that sketch. This one here, I can show the dimensions. We can go into those radius values. So instead of 3, let's give it a 10mm radius, something a bit bigger. We can hide that. The flat pattern's out of date, but honestly, it's not something that we need to worry about. And now that we've got that 10mm, this should be fine. So let's go ahead and grab these, begin to pull it back, and you can see that it's just fine. So again, that 3mm is problematic. It's something that we need to think about. We want to make sure that we go at least to the back of this plate here. So for our dimension, again, we can select something. It's not a parametric relationship, but it does give us something to select. We can say okay. And now we can sketch on the top. And we've got this entire profile here. And what we want to do is we are going to extrude that profile all the way down through, but we want to intersect. We want to only keep what it intersects with. The objects we only want is this bottom object. So not the throttle body plate, not the 5X runner, not the intake top, but only the intake bottom. We're going to say okay, and this leaves us with that bottom sheet metal piece. And once again, we want to test this by creating a flat pattern. We can select a flat face, say okay, make sure that it is able to be flattened. Everything looks good. We finish, and it brings us back to the folded state. So that just leaves us with this little corner piece, which should be pretty straightforward. It's just going top to bottom, but you'll notice that we have a problem here. So this matches just fine, but this piece here Does not. We've got this little bent section. That's something that we're going to need to fix. This can be done one of two ways. We can adjust the plate. We can start to flare the plate out a little bit, or we can come back and we can modify where that little bend happens. So we can have that bend happen a little bit sooner. So the easiest way is to make that bend happen a bit sooner. So what we do is, since we projected everything, we find that sketch. And instead of 20 millimeters here, I'm going to say that's going to start at 10. And then we want to make sure that it happens and is flat before here. You'll notice that there is a slight problem in the bottom. We can fix that in a second. But we want to make sure that it sort of flattens out before here. So let's double click on this. Make sure that the cut is okay. That looks fine. And then let's fix our flange. So that looks okay. And the bottom, let's go ahead and make sure that this bottom piece is okay. So you can see with these, it actually ended up using two different profiles. We need to make sure that the sides are correct. So for profile 2, you can see that they're flipping. So what we're going to do is we're going to reselect these edges. Let's hide this other sketch here. So you can see that it's flipping those. Not ideal, so it's something that we're gonna have to fix. And the way we're going to end up fixing this is going to be redoing part of this sketch. So I'm going to hit cancel here. I'm going to roll back before that and make sure I hide some of this other stuff. Again, don't worry about the flat patterns being out of date. We can update those when we need to. And then let's just go ahead and edit this sketch. So when I edit this sketch, what I want to do is I want to make sure there's not two lines in here. So I'm going to hit X, and I'm going to finish the sketch. And I'm going to try to edit this feature. So I'm going to get rid of that profile, and now you can see that everything's okay. So we want to make sure the side is correct. It's going to be on the outside of that. We'll say okay, and then we'll roll past the extrude and the cut. And what we should see is, well, it still didn't update. All right, so we still need to fix that. It should have been projected from this one, which looks like it's somehow reverted. So let's change this to 40, and we'll go to 30. All right, it looks like it's pretty good. I'm going to go just a little bit shorter. So that first dimension, let's go back here. This first 10 is okay, 10 is okay. We'll make this 28, tighten it up a bit. All right, so now that bend definitely doesn't hit here. This is going to be a little bit tricky in the corner, but it's kind of what we're working with here with this shape. So the next thing that we need to do is we need to create that last piece there, right? So again, another new component, make sure we're using the right rule. This is going to be our intake, and I'm just going to call this a corner piece. So we already have all the geometry. So really what we need to do is just make sure that the front edge and the side edge are not included in that profile. Then when we make our sheet metal piece, we just select that. We'll drag it down. We need to make sure it's on the correct side. So side 2. And it should be, we just need to make sure that it goes to the bottom of this plate here. And then we'll just need to trim the corner out a bit. So we'll say okay. And then for the corner, we just have to pick a direction. So I'm just going to sketch here, rotate this. It becomes a little bit tricky to visualize, but projecting these references should give us all of the things we need in order to create that cut. And now if we take a look at it from the left, we should have a sketch that can be used. We'll say okay. And we'll use our line tool again just to sort of finish that profile off. And we should see a closed profile there. So now if we extrude this, we should be able to extrude it all the way through. It's going to have to go both directions or two sides. Make sure that we cut everything. And then we need to make sure we're only taking the intake corner. We don't want to cut anything else. And this is not going to be ideal here, this corner. It might cause problems when we try to flatten it, but let's try it and see. So flat pattern, pick this flat face, and it did flatten, but you can see that it's caused problems here. So what this means is that when we export this, we're going to want to make sure that we just take this flat face. Another way that you can do this is in 3D. You can use the bend and unbend or fold and unfold. You can pick a stationary face. You can allow it to unfold all the bends, and it'll temporarily flatten it for you. So after we've created this cut, what I'm going to do is right-click and isolate it. And I'm going to create a sketch. Use P on the keyboard to project the edge that we want here. And not the face, we just want this edge and this one here. And then once again, we're just going to sort of finish it off because we don't have the split body tool. And then we are going to extrude it. So what this allows us to do is clean that edge up so that when we do create that flat pattern, it's gonna be fine, and then we can refold the faces. When we refold, just right click and unisolate, or go back to the top and unisolate all. So we'll select that and it'll bring back all those components. All right, so this does bring back our throttle body plate. That throttle body plate is something that we need to deal with. You can see that this corner here, we would need to extend a little bit. So that cut is possibly in the wrong location. We don't really have a good way to extend that out. We just need to fix the cuts. And the last thing that we need on this is a throttle body plate. So we have the TB plate. What I'm going to do is start a sketch, and I'm going to hide it because we also want to project these outside edges and just create a closed rectangle in this case. So what that does is this gives us an extrude region. So we can just fill in, pick all the sections that we want to extrude, and we can pull it out as far as we need to. Join it together if we want. I think in this case we want a new body. Actually, you know what? Let's undo that. Let's undo that, and let's go back to the multi-axis CNC, and then we'll extrude it. So that way it's not going to be a body inside of the sheet metal component. So it's going to be a new body in here. All right, and there we have a 5-axis runner system, and then we have a sheet metal plenum. Now, obviously this isn't necessarily the end of the line. There's a lot more design work to do. That doesn't necessarily look like the fanciest intake, but again, creating it with sheet metal is an important aspect of the design process. So being able to do this, whether or not the runners are multi-axis machined, or if they're somehow the CNC machined version. So if we hide our 5X runner and we're looking at the head flange and the CNC ports. So if it's something like that in the sheet metal, and you kind of can mix and match the different pieces. Now this obviously has a nice 5-axis runner, but it has the sheet metal style manifold. So if anybody's watching this and they want me to do more, continue this design and evolve it, if you want to see a more 5-axis structured intake plenum, then please let me know. I've obviously done 6 of these videos covering various aspects of the design process, and there are so many different directions that you could go with each piece of this puzzle, right? If you're making it out of sheet metal, or if you're making it from off-the-shelf extrusions, or if you're trying to machine some of it, or potentially 3D print and cast some of it. So that's always an option as well. So there are plenty of different ways that you could take this. But If you want to see more of this, please let me know. I'm happy to continue on, and we can sort of scrap the sheet metal part and we can look at continuing on the CNC version where we maybe bolt pieces together. So if you want to see that, please let me know. I'm happy to continue this on. But for now, I think we've covered pretty much everything you need. The basics of setting up the sketches and the features, the basics of creating the plate at the head. In this case, we did it based off of a gasket, a picture of a gasket and some numbers. And then we did a basic extrusion using off-the-shelf runners, off-the-shelf extrusion for the plenum, off-the-shelf injector bungs. Then we moved on to forms and surfaces. For the forms and surfaces intakes, learning how to make a more organic shape. Then we moved on to the CNC-based version where we were looking at splitting it in half and welding it back together. And this version is taking a look at more organic ports and runners, and it sort of morphed into creating a sheet metal plenum. So again, the next version of this could be a CNC machined top and bottom or a bolt together version of a CNC machined plenum. So if you want to see that, please let me know. Happy to continue this on. But for right now, that's as far as we're going to go. If you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.